Welcome to Summarize Science. You've probably heard that AI models can memorize and leak the private data they are trained on. It's a huge privacy concern, and some studies have shown that attackers can literally reconstruct training data directly from a model's parameters. This paper revisits those scary attacks and asks a simple question: just how reliable are they? These attacks work by exploiting the implicit bias of a neural network. Essentially, they create an objective that tries to reverse engineer the training data based on the final state of the trained model. The attacker solves this puzzle to find a dataset that would have resulted in the model they have access to. But here is the brilliant insight from this paper: the solution to that puzzle is not unique. In fact, the researchers prove that there are infinitely many fake datasets that could have produced the exact same model. An attacker looking at the model has no way to tell which one is the real training data. They even developed methods to prove this, which they call splitting and merging. You can take a single data point and mathematically split it into two new, different points. Conversely, you can merge two data points into a single new one. From the attacker's point of view, these new, fake datasets are indistinguishable from the original. This means the success of an attack hinges entirely on the attacker having prior knowledge about the data. For example, if an attacker knows the data is images with pixel values between 0 and 1, they can discard any fake solutions that don't fit that description. Without that prior knowledge, the attacker is lost in a sea of infinite possibilities. The researchers demonstrated this empirically with a fantastic experiment. They trained a model on image data that had been secretly shifted. When the attacker's prior knowledge was correct, the reconstruction was somewhat successful, as you see in the top row. But when the data was shifted far away from what the attacker expected, the reconstruction failed completely, resulting in the blurry mess on the bottom. This confirms that without the right clues, the attack is useless. One of the most remarkable findings is that better trained models are actually harder to attack. Models that have been trained longer and more thoroughly are, in fact, less susceptible to these reconstruction methods. This goes against the common intuition that better models must have memorized more, making them more vulnerable. So, let's recap the key points. First, reconstruction attacks are fundamentally unreliable without prior knowledge of the data. Second, there are infinite, alternative datasets that an attacker could find, making it a guessing game. And third, better trained models can actually be more private. This suggests a new path for privacy. Instead of complex defenses, we could use simple tricks like secretly shifting data to make it much harder for attackers to guess the prior. It's a fascinating result that shows the relationship between a model's performance and its privacy is more complex and hopeful than we once thought.